Hi guys, so today we are making a simple project of a small model of a street light that you can use anywhere else, which is basically a system that switches the positive to a negative, in which this particular sensor senses the ambient light and triggers the entire loop, which goes back to the LEDs and glows. And so this works. But this isn't that great. So extra we have this guy. So we will be keeping him on top and he will be charging the battery. Well, that's our plan. So let's keep these aside and let's see what we are working with. The first thing you can notice is this blue box. What is it? It's a relay. To be specific, it is a 5-volt relay. So what this does is basically you power these two with the positive and negative, and you connect the LEDs to one pin and the negative to the negative and this boy over here. So LDR doesn't produce that much voltage difference for the relay to understand. So to make the relay understand, we have this guy. What is it? A BC547 transistor. So the LDR tells the BC547 what to do. So if it's daytime, it will stop the signal, which will tell the relay to start the lights. Simple but effective. So we have two 220 ohm resistors, as I said, a relay, a BC547 transistor, an LDR, two LEDs, the brightest you can get, the better, a 9-volt battery, jumper wires, breadboard, and for the project, 2 paper straws and a solar panel. So let's move these aside and let's start working on this. So let's first place the relay down like this. So the dot is pointing over here. And what about this leg? It's in the middle. So we take one of these and we stick it in there. Since this middle pin has also to be connected. And this in particular will be cathode. So for the next one, let's move it on here. Here, let's connect it to anode. Next, the other side, this to here. Doubtful, right? Why here? Why not here? Well, take the next one, connect it to cathode, and here. You may understand where this is going now. Now, let's take one more resistor, connect it from here to here Well, now you've already figured it out. So the LDR connect any one lead here, the other lead there, and the transistor with this side facing you, you connect it here. So why are we connecting like this? Let's just take it out for a sec to explain. So to understand the transistor pins, it is basically the flat side straight at you and collector, base, emitter. So collector collects the data, collects the voltage, base is the controlling pin, and emitter emits it. Here we are using the transistor as an amplifier. So now only one pin left, and as you can see here, there is the pin which is right opposite to the dot pin should be connected to here, and then a resistor and it must be connected like this. So now let's try it out. Anode here and cathode here. You heard a pop, didn't you? That was this guy. It works! It's working, guys, it works. So, how will this work? You can look. So now, in the ambient light, there's a lot of light. So this guy sends a voltage to the base. So this guy, the transistor, he is like the brain of the circuit. He takes this voltage. It's very small, but still, it's good for him. So, since this is 9 entire volts rushing through this guy, he'll just blow out immediately. But this guy over here, a resistor, resists the 9 volts into a much safer voltage, which this guy is happy with. And so, as I said, this pin, which is the cathode, and here the cathode, and so electrons would like to escape to here, but since now the ambient light is there, the LDR is telling the transistor via the resistor that no, do not allow the electrons to flow from the cathode of the relay to the cathode of the battery. So, it doesn't work. The LED doesn't glow, since there's nowhere for the electricity to go and complete the coil. And so it's stuck. What can we do? Well, if we simulate night time or just stop this guy from knowing it's daytime, now it's telling the transistor, oh, it's day, day has stopped, it's night time, now you can let them flow. And so the cathode goes, it creates a magnetic field, and so the common pin switches to this side and the LED glows. Simple. And so when we leave it, it tells, hey, it's day again. Now stop allowing the electrons to flow. Simple. So, one more question you may ask. Why cathode? Why not anode? Well, then we'll have to deal with 9 entire volts rushing through this guy. If we reduce it to some safer voltage, what about him? He won't operate. This guy needs small voltages like 1.5 or 0.5 volts is enough for him. It's more than enough for him. But this guy needs a minimum of 5 volts. 1.5, he just says, nah man, I'm not gonna do it. But we need both of them to work. So, this guy can handle cathodes. So we gave him cathode and we let the relay handle anode. And one more question you may ask, why not add a more powerful transistor? 1. Heat and 2. Complexity. If we make this system, it's quite easy. And if we add a bigger transistor, 1, we have to reconfigure everything. Well, that's okay. And 2, we have to make sure that that cools perfectly. And when that cools, something else will get hot. We have to make sure that cools perfectly so that that doesn't break. And if that breaks, well, say goodbye to your project. So that's why we've made this simple but effective system. So, how do we make this into the project I was talking about? Here comes our rest of the stuff. So with these stuff, I'll show you what we're making. We'll cut these straws into smaller lengths like this, approximately this high, and the solar panel will be here. We will solder 2 wires from here into the anode and cathode with diodes, that is white diodes. Since we don't want this solar panel to get burnt off from the sheer voltage from the battery. So example, the battery died. Who will provide the system with voltage? Solar panel. Example, the solar panel cannot function. Who will provide the system with power? The battery. Example, the battery is dead and it's morning. While the solar panel can power this as well as this simultaneously. And when it's night time, the charge that the batteries got from the solar panel will provide this system to work accordingly. So it's an all-out loop. Hope you've understood what I said. And let's get building. And so we'll put this here. We'll take 2 wires, the cathode and the anode, send them to the battery like this. And then, as you know, we'll cut these 2 like this. We might bend them a bit so that it becomes something like this. And then we might attach both the LEDs like this. So that's our plan, and we'll extend these guys. This guy over here can go on top. So what about this guy? Confusing, huh? Well, this guy, let's just put it short and keep him here. And so this guy can go around and stick out like this. So we don't need to get 6 volts directly going into the transistor. The transistor will die. And if we resist it too much, the transistor won't function. So for just the right amount is provided with the LDR. And the LDR has much more precise daylight detection than a solar panel. The solar panel is designed to create voltage from sunlight, not detect sunlight, which the LDR is designed to do. So that's why we have both these stuff. And so the LDR will be poking out here, the solar panel here. We'll get the wires out, create 4 wires, 2 from the solar, 2 from the LDR, get them through the tube, get them back to the system, and then it's done. And we'll also have another set of wires going up, splitting out for both the LEDs. And as you saw, they're bright. So I wouldn't be expecting a teeny tiny LED that can produce half the brightness as this guy. So that's why I especially said the brighter the LED, the better. So let's go and do the stuff. So guys, to insulate it, I have taken the biggest heat shrink I can. I didn't have one which was apt for this, so that's why I took this. So we'll keep it in after soldering. And so let's just estimate how much we will need. Around this much, right? Let's fold this in half and cut number 1 here. Keep the rest aside. Cut number 2 in the fold. Ta-da! So let's save it aside. Let's take our red hot piece of metal, smoking. Now it's smoking hot, so let's solder it up. So first we have the soldering lead. Yeah, look at that. So guys, the cathode section soldered. Now the anode to go. Let's do it. Okay, great. It got stuck, so I'll have to move it around a bit. And now, kaboom! That part done. Yep, so this wire has been entirely soldered. And the rest of the stuff aside, and let's both these lamp posts are to be connected. Take the solar panel, and since the glue is drying, we can set the wire on top so it stays there. Lamps can get fixed into the solar panel directly. So as you can see, this is the top view. Now at least, as I told you, we will have to add this bad boy. First of all, pour some glue here. So now we have this teeny miny sensor sticking right above the solar panel. So guys, as you can see, it turned off since now there's light in the room. So guys, as you can see, now it's dark and the lights are glowing. So now the lights have turned off again, which definitely does in fact mean that the system works. So when we turn it off, the two LEDs will glow as well, and when sunlight hits the solar panel, it will charge the battery as well. So just one thing to be clear, never ever try to use a normal one-time use battery, since then it might explode when it gets overcharged from the solar panel. So just a reminder about that, and otherwise you can make it at home, and it's a simple project which is very easy to make, as you saw. Thank you for watching and see you in the next video. Bye.